Well, here we have an equation, and we need to go ahead and sketch our graph. Well, your a value is always what's in front of your trig function. In that case, a is 3. So that means our amplitude would also be 3. That means when we get done, we'll be going 3 units above and below the horizontal line that cuts your graph in half. Your b value here is 2. That's the number in front of x. Remember, that affects your period. So you could use your peanut butter equation of PB, so your period times your b value is equal to 2 pi. When you solve that for what your period is for p, you end up getting your period to be pi. Now d is this right here, the 2, so that means you're going to be shifting your graph 2 units up. We also have c being negative pi over 4, which means you will be shifting your graph pi over 4, a fourth of a unit to the right. Now, what I normally like to do is I need to start out with my basic sine graph. Remember, sine starts at the origin, goes up to a height of 1, curves back down to a depth of -1, and then curves back up. I like to be able to graph that without any tick marks on my axes. So I draw my axes, draw in my basic trig function. Then, after I have the trig function drawn in, then I mark on there where my period is. After one complete period of going up, down, and up again, I would mark my period, in this case of pi. I also know that when it maxes out at the top, I got to be 3 units up because that's my amplitude. When it bottoms out at the bottom, I got to be 3 units below because that's my amplitude. So if we just go ahead and do that, we end up getting this blue graph. Yes, there's a lot here. Don't get overwhelmed by it. There wasn't any easy way I could go ahead and get them all in there one at a time. So after we have our basic blue graph in here, which is our sine graph with an amplitude of 3 and a period of pi, we now got to go ahead and do the other things. Whether you do the shifting up first or shifting over first does not really make a difference. In this case, we're going to have to go ahead and take this whole blue graph and move it 2 units up. So I'm going to take my maximum, go 2 units up. Take where it crosses here, go 2 units up. Take my minimum, 2 units up. Take where it's crossing my axes, 2 units up. Take where it's crossing here, 2 units up. Take where I started out at the origin, 2 units up. When I do that, it gives me all these new points for me to be able to go ahead and draw my graph through. Because I'm just going 2 units up from all these other points. Once I have these points, then I just go ahead and sketch in a nice smooth curve, and that gives me my red graph. The red graph has an amplitude of 3, period of pi, and has that vertical movement. The only thing I have left to do is to go ahead and move everything a fourth of a unit to the right. Well, we started out here at 0. We knew one complete period was pi, so that means halfway in between here is pi over 2. I also know that halfway in between 0 and pi over 2 is pi over 4. That's how far I need to go ahead and move everything over. So I need to take this, move it over a fourth of a pi. This one, move it over a fourth of a pi. This one, move it over a fourth of a pi. This one, move it over a fourth of a pi. This one, move it over a fourth of a pi. And then I draw a new smooth curve going through the pink. And that gives me my green graph, which is my final graph. Well, we more or less need to do the same thing for this one here. The number in front is my A. So that I know that my A is -4, so my amplitude is absolute value of that or 4. So I know I'll go 4 units above and below that horizontal line that cuts my graph in half. Now my B value is what's in front of X. So my B value is 2. I know that B affects the period, so I could use that peanut butter equation. Remember, I could go my period times my B value is equal to my normal period of 2 pi, solve it for P, and that's how we get this. Now, to be able to figure out what C is, you need to have it in the proper form. The proper form means you need to have y is equal to an A cosine B and x minus c plus a d. We got to have this extra set of parentheses in here. So I need to look at this and I need to factor out a 2. When I factor that 2 out, I end up getting this. So therefore, my c value is pi over 6, and since it's plus, I know I'm going to have a phase shift of pi over 6 to the left. The negative that I have right here in front, that just lets me know that I'm going to have a reflection over my x-axis. Now I'm starting out with my basic cosine graph. My cosine graph, I would know, would start out, my basic cosine graph I know would start out at the top, go down, and then come back up. However, I know that I have a negative in front, so this really needs to be flipped upside down. So it's more or less going to start at the bottom, go up, and then come back down. So from that, I want to go ahead and draw in one complete period, which I know would be pi. I know my amplitude is 4, so I'm going to max out at a height of 4, bottom out at a height of -4. And so that's what I have drawn over here in red on my graph. Bottoms out at 4, maxes out at 4, bottoms back out at 4 again. One complete period is pi units over. So drawing in your tick marks after you have your basic graph done allows you to be able to accomplish 2 of the 4 things, or in this case 3 things, for our graph. The only thing we have left to do is to take this red graph, move everything 1/6 of a pi to the left. 1/6 of a pi, well, here's a half a pi. 1/6 of a pi would be 1/3 of that. So I need to move everything 1/3 of a unit over. So for the most part, what I have right here is letting me know how far I need to move everything over. So I need to go to my key points down here at the bottom, and I need to move it that far to the left. I need to go here, move it that far to the left. Need to go to the top of the red curve, move it that far to the left, and put a point. Here, where it's crossing, I got to move it that far to the left. Here at the bottom, I got to move it that far to the left, and so on, move it that far to the left. So then I get all those points from moving everything 1/4 of a pi to the left, and then I draw in a smooth curve connecting all those, and that's how I get the green graph. And the green graph is my final graph.